So today we'll be discussing the crystal field theory, which is a qualitative model that describes the strength of a metal ligand bond. So we will be using 3 complex ions to help explain this theory, each with a different ligand, a different strength ligand attached. So our first example, pentaamine chlorocobalt 3, has 6 electrons in its metal. Although this solution absorbs the yellow color, the color reflected is violet. This has a high spin with a long wavelength and a low frequency. Pentaamine aqua cobalt 3 also has 6 electrons in its d orbital, but this compound has a slightly higher crystal field split, but because the ligand is also weak, it shares the same properties as the pentaamine chlorocobalt 3 complex ion. Because both of these ions have unpaired electrons, they are paramagnetic. Hexaamine cobalt 3 has ammonia as a strong ligand, which will cause the electrons in the cobalt 3 to pair up in the d orbital. This will give this complex ion a low spin, a short wavelength, and a high frequency. And due to the pairing of the electrons, a diamagnetic property. This complex ion also has the largest crystal field energy, largest splitting crystal field energy because of the ammonia.
Now, the shape of the 3 complex ions are all octahedral. The reason being is because they all exhibit 6 coordination numbers. If we look at the ligands, right here, they all add up to 6 coordination numbers. So therefore, that's how octahedral. And I can also show you an example of the shape of octahedral, where we would have cobalt as our central atom. Alright, and let's just use hexaamine cobalt 3 an example, because it's easy. So at these 4 tips, right, or 6 I should say, they all bond to NH3. And as you can see from here, it is octahedral. So now I'm going to attempt to draw the valence bond theory for pentaamine chlorocobalt 3. So cobalt 3 has 60 electrons in the 3d orbital. 1, 2, 3, 4, 5, 6. And because it is a weak field, it does not have to go to excited state. so therefore, all we have to do is just hybridize this with the 4D. So they would hybridize, and you would just get sp3d2.
Got ready, Kingston, to start lecture.
And then we would show NH3 and chlorine sigma bond. So 1, 2, 3, 5, and this would be chlorine, right? And there you have it. This is your valence bond theory. It is a weak field, so we do not need to. Go into an excited state. Therefore, the shape is octahedral sp3d2. So this is the color wheel. It's going to be used a lot in explaining how the colors are absorbed and what color is observed. So, for example, cobalt or hexamine cobalt 3, right? We would predict that it absorbs blue, and therefore we would observe orange. See the connection? Now, it also depends on the ligands, and for example, hexacyanocobaltus 3, right, is a strong filled. Well, cyano is a strong filled ligand, so we would expect it to be, very, very violet to like almost dark. Dark black absorbance. So we would get a clear solution. So, and also because it is a low spin, which means it has short wavelength and high frequency. And that concludes our presentation. Thank you for watching. I hope you enjoyed.